A general overview of statistics would include distinguishing between descriptive statistics and inferential statistics. We will primarily be working with basic descriptive statistics, which includes graphs, charts, averages, standard deviation, etc. The intent being to quantitatively describe the main features of a collection of data or scores. On the other hand, inferential statistics involves taking a sample of scores from a population and inferring from the sample what is hypothesized to be true of the population. Both look at a sample from some population, with the difference being what is done with the sample, summarizing or describing as opposed to representing or inferring. I like to use the example, for instance, of wanting to know the average weight of the incoming male freshman at LU. Let's say that there are 1,000. We could actually add the individual weights these guys have and divide by 1,000 and find the average or mean. You might think that's too much trouble and say, why don't we take a small group or sample of, say, 50 students and find the average or mean, and then infer from the sample what we believe to be true of the larger group or population. This, in a nutshell, is inferential statistics. In describing data, there are three measures of central tendency: the mean or average, the median or middle score, and the mode, the most frequently occurring value. Generally, the mean is the best measure of central tendency since each score contributes to the value. In some cases, the median is preferred if there is one or two values that skew the data. I use the example of someone moving to a small town in West Virginia where the average or mean salary is $60,000 per year. However, when they get there, they find out that it is a small coal mining town where the owner of the coal mine is a millionaire, and when his salary is averaged in with the others, many making $10,000 to $20,000 per year, the average is indeed $60,000. This is a true value but misleading. The better way would be to refer to the median income, which is unaffected by the one extreme value or score. The mode is also helpful in describing data, but is generally considered the weakest measure of central tendency. Another way to analyze or describe data is to look at the variability or dispersion of these values. The four major measures include the average deviation, standard deviation, quartile deviation, and the range. The simplest is the range, which is the difference between the high and low scores. Some would say the difference between the high and low plus 1. So for the following scores, 12, 11, 10, 9, and 8, the difference would be 12 minus 8 equals 4, or some would say 12 minus 8 equals 4 plus 1, which is 5. The term deviation refers to how much the individual score deviates from the mean. Theoretically, the sum of these deviation scores is equal to 0. There is an equal amount of deviation above the mean as below the mean. If you add the absolute or non-negative value of these deviations and divide by the number of scores, you would have the average deviation. The standard deviation is the preferred measure of the variability and can be calculated by squaring these deviation scores and taking the square root of the sum of the squared deviation values divided by n, or the number of scores. For a student in two separate classes, knowing the measure of central tendency, or mean, and the measure of variability, or standard deviation, along with the raw scores of the student, we can determine in which class the student performed better. This is done by first standardizing the scores and then comparing the standardized scores. Two of the most popular standard scores are the z-score and the t-score. Comparing the raw scores without standardizing them is like comparing apples and oranges. What is a z-score? It's a measure of the distance each score or observation is from the mean or the values. If a z-score is 0, it is on the mean. If it is positive, it is above the mean, and if negative, below the mean. If a z-score is 1, it is one standard deviation among the mean. So, for example, if it is negative 2, this means it is 2 standard deviations below the mean. The formula for computing a z-score is given for both populations and samples. We call the values of a population parameters and the value of a sample statistics. The z-score for a population is shown where x is the raw score, and the numbers on the top, x minus the population mean, And on the bottom is going to be the population standard deviation. For a sample, again, X on the top is the raw score, X bar is the sample mean, and SD stands for the sample standard deviation. The z-score and the t-score primarily say the same thing. To determine the t-score, multiply the z-score by 10 and add 50. Therefore, a z-score of 0 would be equal to a t-score of 50. The benefit of using the t-score is it is always positive and does not have decimals for the most part. A z-score of negative 1.2 is equal to a t-score of 38. The standard normal curve is best explained as a z-score of 1 would be 1 standard deviation above the mean and represent 34.13% of the area under the curve. A z-score of 2 would represent 34.13% plus 13.59%, or a total of 47.72% of the area under the curve. Another way of saying this is that approximately 68% of the scores would be from 1 z below the mean, where z equals negative 1, to 1 z above the mean, or z equals 1. Also, approximately 95% would be from between z equals negative 2 to z equals positive 2. If the mean score is 500 and the standard deviation is 100, as is the case used by the SAT or the GRE, 680 of 1,000 people, or 68%, who took the test would score between the values of 400 to 600. Similarly, 95%, or 950 out of 1,000 who have scores between 300 to 700, which is 2 standard deviations above and below the mean. Your textbook does a great job of showing a standard normal distribution with the z values and the t values and the percentile ranges, so make sure to check that out in your textbook.